For section 11.1, this is the introduction to sequences and series. To start off with, we have a little bit of vocabulary. So if you see the variable n in this chapter, that is going to represent the term's number. So an example, if n is equal to 10, that means it is the 10th term. And then the terms, those are the numbers in a sequence. And a sequence is just a list of values that are going to be following a rule. We have finite and infinite sequences. Finite means it has a specific number of terms, and infinite means it's going to continue without stopping. Then we have series, and so for a sequence, it's a list of numbers that are listed out separated by a comma. Series, it's going to be very similar to that, but instead they're going to be added together instead of them being listed. So if you need to pause to write down these definitions, you can do that before moving on to the examples. Okay, so for example 1, they want us to write the first 6 terms. Just for the sake of time, these ones are pretty easy. We're just going to do the first 3 terms of the sequence. So that means we're looking for when n equals 1, and n equals 2, and n equals 3. When we have our rules this chapter, we are going to use a sub n, and sub means a subscript. It's like the opposite of an exponent. An exponent is a superscript where it's up on the top and it's written little. The subscripts are little and they're written a little bit below your letter. So when we have a sub 1, that just means we're replacing n in the equation or the rule with a 1. So we'll have 2 times 1 plus 3, and that's going to equal 5. Same thing for when we have a sub 2, we're going to then substitute a 2 in for n, and then evaluate, and this one would equal 7. Then for a sub 3, we'll substitute in a 3 and evaluate, and that will give us 9. So the first 3 terms of this sequence are going to be 5, 7, 9. And a lot of times they'll be listed out like this in a list format. All right. For the next one, they want, again, the first 3. So we're going to find when n equals 1, n equals 2, and n equals 3. This test will be a calculator test. So you are going to be able to use your calculator on this. So the first one, we would have negative 2 to the power of 1 minus 1. So the exponent's going to be 0, and anything to the power of 0 equals 1. Then for our second term, we would have negative 2 to the power of 2 minus 1, which equals 1. So negative 2 to the power of 1 is just negative 2. And then we have negative 2 to the power of 3 minus 1. That exponent would equal 2, and negative 2 squared is going to be positive 4. Now, if you are using this on your calculator, you need to make sure you put parentheses around the negative 2 with your exponent on the outside. Otherwise, when you type in a problem like when f equaled 1 and f equaled 3, you would get the answers negative 1 and negative 4 if you did not have parentheses. So the parentheses do change the sign of your answer. It's important that you have those. Okay. So for these rules, we could plug in any number for n, and we would be able to figure out what that term equaled. So when we are able to do that, these are called explicit rules. For explicit rules, again, like I just said, you can find any term in any order. Perfect. Okay, for example 2, this is when we have recursive rules. Recursive rules, you have to find the terms in order, so you cannot skip any. So you have to find Okay, these also have two parts. So if we look at these rules, let's look at example A. They're telling us that a sub 1 equals 3, and then they give us the rule a sub n equals a sub n minus 1 minus 2. This part here, where it has a sub n minus 1, that means the previous term. So because we have the previous term as part of our rule, that means in order to find a term, we need to know the term before it as well. So an example, let's go, and we already know we're finding the first four terms. We know the first term is equal to 3. So let's find our second term. So if our n value equals 2, that means when we substitute in that 2, we would have a sub 2 minus 1, and then minus 2. And if we simplify that, it would be just a sub 1 minus 2. And we already know from before that a sub 1 equals 3. So we can plug in a 3. And 3 minus 2 equals 1. So if you can see the pattern here, wherever we have that a sub n minus 1, that just means, again, the previous term. You can skip showing all of these steps that I have shown right here. So if you can skip that because you know it's just the previous term, that is okay to do. All right, so let's look at a sub 3. Again, that's going to equal our previous term, which was 1, minus 2. So a sub 3 is going to equal negative 1. Now we can find a sub 4, which again starts with the previous term, negative 1, minus 2. A sub 4 is going to equal negative 3. So you can see every time we just took that previous term and then we subtracted 2 from it to get the next term. And that is what a recursive rule is. It's telling you what change is occurring to get to the next term. All right, so I would recommend pausing and trying example B on your own, and then pressing play to see if you got it correct. Okay, so for this one, a sub 1 equals 10, and we need to find a sub 2. Now for this one, we have the previous term plus 2n minus 1. So my previous term was 10, so I'm going to plug that in. And then it's plus 2 times your n value. And remember, n is this little number, the sub note of a. So I'm going to take 2 times 2, and then minus 1. Now I'm able to figure out what this equals, and that's going to come out to be 13. Then when I find a sub 3, again, the rule starts with the previous term, so I'm going to take the 13, which was my previous term, plus 2 times n, and in this example, or this problem, my n value is now 3, minus 1. And again, I'm going to figure out what that equals. This one would come out to be 18. And now I can find a sub 4. I know my previous term was 18, and then I'm going to add 2 times my n value, which is 4, and then minus 1. And when I type all of that in, I am going to get 25. And that gives me the first 4 terms of this sequence. So when you're writing rules, you have to make sure you read the directions. Sometimes it's going to ask for the explicit rule, and sometimes it's going to ask for the recursive rules. When you are using them, if you are finding random terms, it's going to be easier to use the explicit rule. If you are finding terms in order, it's okay to use the recursive rule because you would need the previous one to find the next term. But if we were looking for the 99th term, it would take you a long time to get there if you're using the recursive rule instead of the explicit.